Okay, running through a couple more problems, trying to get the same base for your exponential equations if you don't have the same base. So having a calculator, it's going to be pretty darn near impossible if you don't use a calculator. But notice we don't have the same base. On the left side, the base is 64. On the right side, the base is 512. So what you can try on your calculator is 64 to some exponent, like 64 squared is 4,096. So that's too big. Kind of like the last example then, I can't just rewrite this side of the equation in terms of the base on the left side, even though the base on the left side is a smaller base. So I might need to change and will have to change the base on each side of the equation. Here's what you're going to have to need to recognize. 64, you want to try to rewrite that in terms of some base. 64, you really should know that that's 8 squared. So I'm going to rewrite this in terms of 8. 8 squared, or 8 times 8 is 64. That's what I just circled. We still have the exponent, x plus 1. And then I'll try to need to rewrite 512 in terms of the base 8. So you probably need your calculator. Maybe try 8 to the third power, and that exactly works. 8 to the third power is 512. So on the right side, 512 is 8 to the third power. And then that was already to the x power. Now I have the exact same base, except what I'm going to do is apply the power of the power rule, multiply the exponents. So on the left side, I want to multiply 2 times x plus 1. So it's 8 to the 2 times x is 2x. 2 times 1 is positive 2. And then on the right side, it's just 3 times x. So it's 8 to the 3x power. We have the exact same base on each side of the equation, so we could set the exponents equal to each other. 2x plus 2 is equal to 3x. If I subtract x from each side of the equation, 2x from each side of the equation, then 2 is equal to x, or x is equal to 2. And then I'm actually going to check that. So if I substitute 2 into the left side of my original equation, then it's 64 to the 2 plus 1, that's 3 to the third power, should equal 512 to the x power, and then x is 2. So now I could check on my calculator if 64 to the third power, so 64 to the third power is 262,144. And then on the right side, 512 squared is the exact same number. So it checks out. Our solution is correct. And then for this last example, we have fractions. So people don't like fractions, but we still need to deal with fractions. So there's a couple of different approaches that you can take. I could try to make the 2401 a fraction, but here's what I'm going to do. Since people don't like dealing with fractions, I'm going to make this a non-fraction. Instead of 1/7, I'm going to make it 7, or 7 over 1. What I actually did is take the reciprocal of that. It's actually 7 to the negative first power, and that's to the x power, because 7 to the negative first power is the same as 1/7. And then I can multiply these exponents by using the power of a power rule. So 7 to the negative x power equals 2401. So I got rid of the fraction, and for most people, now it should be a lot easier to deal with. I could have made this a fraction, but then I'd have a fraction on the left side, a fraction on the right side, and then people would really worry about that. But I want to try to rewrite 2,401 in terms of the base 7. And if I can't write 2,401 in terms of the base 7, we wouldn't really be able to solve this, because 7, I can't rewrite that in terms of a different base. 7 is a prime number. So you might just need to play around on your calculator. 7 to the third power, or 7 cubed, is 343, so that's too small. And I could take 7 to the fourth power. That's 2,401. So 7 to the negative x power is equal to 2,401 is the same as 7 to the fourth power. Now we have the exact same base, so we could set the exponents equal to each other. Negative x is equal to 4. If I solve this for x, what's in front of the variable here, x, even though it's just a negative, it's also the same as negative 1. So I want to divide each side by a -1. And then x is equal to 4 divided by -1 is -4. And then kind of like on all the other examples as well, I'm going to check the solution. So on the left side, I'm going to start with the original equation. 1/7 to the -4th power should equal 2,401. Okay, but here's what I'm going to do. Just show you on my calculator how we can check that. If I'm checking it on my calculator here, I'm going to take in parentheses 1/7, so 1 divided by 7. Use my exponent. I could use a negative exponent to the -4th power. If you're using a negative exponent, let me zoom out so I could show you here. Even though mathematically a negative is the same as minus or subtraction, if you're using a negative, if you can see this very bottom button here, lower right-hand corner next to enter, that's the negative. This is subtraction. Not exactly sure why it's that way on the calculator, because a negative and subtraction are really the same mathematically, but on your calculator, there are two different buttons. But I'm taking 1/7 to the -4th power, 2,401. That's what we had, so it does check.